Hello, my name is ADHIKARI and I work here in Dallas office. Today I would like to demonstrate a lean BIM practice mantra. The prime objective is to model 3D elements that contribute toward making volume of the building. This means you model elements like walls and ceilings and anything that gives you important dimensional references. These volumetric elements provide you with necessary background that we build details into. Such practice will provide a well-coordinated process to put buildings together. Using Revit to focus on volumetric elements as 3D and utilizing detail items to fill in the details makes us efficient and effective. Let's take a look at an example. Here I have modeled an assembly of walls where my internal load bearing is a 8-inch CMU and the outside wall is a volumetric representation of the metal panel cladding system. If I were to inspect the wall thicknesses, you can see how these are 8-inch thick, which is also 7/5/8. Check here as a thickness, so there's your total thickness 7/5/8. And if I were to check the thickness of the metal panel cladding system, then you can see the structure is made out of 6 1/8. So you can see there's a thermal layer insulation of 5 inches, some vapor barrier representation, a air gap, and a finish of 7/5/8, which is the actual thickness of the metal panel itself. Here, my choice of modeling walls as a simple walls is advantageous in Revit. Anybody can tackle modeling simple walls, and also modeling metal panels in 3D don't bring any advantages while documenting for construction. Typically, this is a system which will work well within the given dimensional volume. So as an architect, we might focus on making sure there is enough room for the system to go together. Let's take a look at a section I prepared earlier. So here's my section through the wall, and this is how the section looks like. In this section, the necessary graphics needed to document the wall section is provided by the model elements, and the detail items I've superimposed on top of it. Because section is a 2D view, we can utilize annotations to elaborate on the 3D volume as a background. In this example, the graphic to represent CMU and concrete that is represented by crosshatch is displayed by the base material used in the wall itself. The details such as necessary sill blocking, steel to support window frame, flashing, connector, CMU block finishing, and mortar joints and reinforcements are superimposed on top of the modeled volume. Here I have used a combination of detail items and repeating details. If I move these aside, you'll see how these are put together to make your wall details. Let's take an example of this detail item here. When I select the detail item and click on Edit Family, you can quickly discover that this is a detail item family. This can be confirmed by clicking on the Family Category and Parameters button here, and that tells me it's a detail items. Like many families, detail items provide you with two major reference planes. One is center left right and the other is center front back. The intersection between these two reference planes works as your insertion point for the family when you place it back in your project. The elements that define the details themselves are annotation lines. You can create lines from the command line found in Create menu. It is important that when you draw lines to keep in mind that these major reference planes are representing a major reference in your model wall. Like for example, this insertion point will dictate the front surface of the wall that this detail item will go and superimpose on top. A quick observation here is you can see the nominal cut lumber section is another family embedded in this. Also, the section for the angle is also provided by Autodesk. Here's another family that is a detail item as well. It's a combination of nested families that I have assembled together. Just like other regular families, dimensions and the label used in the dimensions can control the flexibility while at the project level. These are instance dimensions that you can adjust the position of these fasteners. So for example, if I were to move this dimension to 6 inches, then you can see how all the geometries kind of move to represent that. Also, it is very important to keep in mind that these elements, the detail lines that I've made, are not locked or anything. The way it works is in the background, Revit produces what's called auto sketch dimension. If I do VV and go to annotation categories, you can see automatic sketch dimensions are turned off by default. So if I turn that on, you can see all these numbers that actually are controlling the lines and its relationship with the reference planes. If you want to control, you can convert these into irregular dimensions. You create a new dimension to replace it, then it gets overridden by it. To conclude, a careful combination of model elements and detail items makes for economic best practice. If every one of us learn to do this and find a way to collectively share these components, will we be better off working as Team Gensler. Thank you so much for your attention. Happy BIMing. See you next time.